Hello everyone, welcome back to Calculus. We are in the discussion of chain rule. Here it is, the chain rule right here. This is the chain rule. dy dx is dy du times du dx. And also we do have somewhat specific cases. The basic formulas combined with the chain rule, power rule combined with the chain rule. That's the so-called general power rule, the exponential function, and more generalized exponential function, sine function and the generalized sine function, cosine function and the generalized cosine function. And also, we didn't look at the situation, the chain rule combined with product rule and the quotient rule. And as I mentioned earlier, I do consider chain rule is very hard, very difficult to understand. And indeed, even you know all those things very well, and we may still have more complicated cases for the chain rule. And basically, chain rule, it is used to find out derivatives when you have the composition of two functions. And indeed, speaking, the composition or the composites of two functions, we could have the composition or composites of three or more functions. That is the situation. So let's take a quick look. If I can walk you through with those two examples. And they are all on the textbook. Example 3.55. Example 3.55. It is to find out derivative. Derivative, it's a kind of more complicated situation as you may expect. Cosine to the 4, then 7x squared plus 1. And first of all, do understand the power of 4, the meaning of power of 4. It simply means the entire cosine part to the power of 4. Entire cosine part to the power of 4. Okay. So what I decided, realizing k it is a entire cosine part to the power 4, I simply taking this cosine function as u. And then I hope you see u is the composite, not a single cosine, it should be clear. Then u, to calculate the derivative of u, it requires the product, the chain rule, right? So du dx, really it is from the chain rule. Or if you want, you can use the generalized rule for the derivative of cosine and the cosine here. Okay. Certainly in this case, it is a derivative of cosine. So derivative of cosine tends to be sine. Then times the derivative from inside. I have 14x in the front. This part of the calculation already involves with the chain rule, or I use the chain rule once. And furthermore, if we look at the situation, we want to calculate the derivative of this k, right? K is a function of variable x. So k is a function of u to the 4. So we do know dk du, it is 4 times u to the power 3. That's a power rule. And then du dx, it is from the chain rule. So I hope it's clear to you too. Okay, we did use the chain rule two times. And then in the end, we still want to get everything back to x. So this is my arrangement. 4 times 14. I believe I made the number wrong here. It should be 56, right? 4 times 14. 56. The single x still stays. U to the 3, really, it is cosine to the 3. So somewhat I just keep the same relatively easy, simple thing in the front first. Sine goes first. And then I'm having cosine to the power 3. Keep in mind the cosine, it is for 7x squared plus 1, the entire thing, not just cosine, a single term. Okay. So this one, it is solved using chain rule 2 times. And indeed, the function, I'm not sure how you say it. I'm seeing the function is very much complicated. It is the composite of three functions, so does require chain rule 2 times. It's on the textbook, example 3.55. Let's take a quick look at another example, a similar example. Indeed, it is also on the textbook, and there's no solution on the book, so I'm trying to provide the solution and also try to see if I can give a quick explanation how I reach to the derivative or how the chain rule works really. Okay. First of all, still it is to clarify this h of x equals sine to the 6 really would be sine of the entire thing then raised to the power 6. So what I did is I just created u as 4 sine of x cubed, the entire thing. The very simple reason is taking u as this sine of x cubed, indeed I did, consider h as u to the power of 6 as I wrote here, right? H is u to the 6, which means I could calculate dh du, which is 6 times u to the 5. And also, according to the chain rule, or indeed according to the way we create u is du dx, so it is 3x squared cosine x cubed. This part involved with the chain rule, right? So chain rule, it is already used once for this part of the calculation. Then h prime, the calculation h prime requires the chain rule again. So we got the chain rule 2 times, and also we don't want to scare you. And sometimes we may have functions involve chain rule even more than 2 times. But anyway, I guess for our class purpose, mostly you only need to understand when we have chain rule 2 times, when you need to use chain rule 2 times for a single problem. Okay. And then the last part, it is about the writing. How do you recognize a function is simplified or not? Clearly, when you have u and x mixed, it's not a good answer. You got to get everything back to x. Okay. And then I guess you want to have numbers first. Actually, I just figured out 3 times 6 cannot be 15, right? Should be 18. Should be 18. Then there's the term x squared. You want to keep x squared there. Then there's between sine and the cosine. Somewhat, I guess it really doesn't matter which one goes first. But anyway, in general, I guess you want to get the term with lower power first. So I'm having cosine first this time. And then sine in the end, because sine it is itself, it is raised to the power 5. That is the derivative of the function given here, and it does require chain rule 2 times. And again, for our consideration or our requirement here is that you may only need to know how to apply chain rule 2 times for a single problem. So I say that should be it about about the chain rule. And you can consider this as a formula for the chain rule. Remember the DD notation. I say du dk k prime, it is really dk dx. Or let me just put it here. K prime, it is dk dx. Okay. And what we can get here is dk du dx, multiply them together, that tends to be dk dx. And also, this is what I presented in the very beginning for the chain rule. You use dy dx. dy dx is dy du times du dx. And also we mentioned that if you really don't feel comfortable with the chain rule for now, it happens a lot. Actually, I say it is a common situation. Then if that is the case, your task is try to remember those at least 4 of those additional rules. General power rule for the general exponential function, general sine, and the general cosine. Section 3.6, chain rule. Thank you for watching.